All right, here we go. Find exact value. That means no calc. 7.2 is a continuation of 7.1, which is now we're adding on cosecant, secant, and cotangent, okay? So, sine composed with tangent inverse of 1/2. Question number 1. Is 1/2 an angle or 1/2 a ratio? A ratio. Oh, you guys are beautiful. Okay. If it is a ratio, is it possible that we can put it on a triangle? Good. Now you also have to decide. You have 4 quadrants. Can I draw this triangle anywhere I want? No. You're limited to what? 2 quads? 1 and 4. It's a positive ratio, so where are you going to draw it? 1. Yep, draw it out. Okay. The right angle, put it on the x-axis always. All right, label this triangle for me. What goes where? Ben?
The vertical side is 1, the horizontal side is 2, and the
hypotenuse
is something in between.
Okay, something bigger. A squared plus b squared equals c squared, right?
Yep.
All right, so that's 1 square plus 4 equals c squared. So c is rad 5. Beautiful. All right, can I have rad 5 as negative, by the way? No. Okay. So if I said, hey, find tangent inverse of 1/2, are you going to end up with another ratio, or are you going to end up with some angle? Some angle. Let's call this angle theta. Okay? That means this whole thing is pretty much what? The whole thing, tangent inverse 1/2, is just a what? Just a theta. I don't know what theta is. I don't have a calculator. But I don't really care because that's not the stop, right? The final stop is really for me to find sine of that theta. Would you agree? Yes. I have this beautiful picture. Let's call theta. So what's sine of that? 1 over rad 5. Can I leave that as an answer? No. So it's really rad 5 over 5. And that's how we do it. All right, B and C. I would like for you and your team to complete that. Let me put 5 minutes on the clock, and then I'm going to please talk it out, teach someone, help someone. Yes, I will. Let's see. I'm looking for and then another homework was like 11 of 20 So I bought this. It was some people printed it out. There you go. You got it. There you go. I know. That's one of them.
I got the same.
Page 3. Yeah. And then I will trust you all the way to page 8. Wait, no, page 8. I and C. Oh, then I did not see that. Okay, well, two red, two blue. I don't know.
Inverse cosine 1, 2.
Yes. Oh, it's inverse. What?
Yeah, it's inverse
Alright.
Not a 1, 2.
I'm gonna go like that way, so I'm not missing anything. Okay. Page 3 is one of them, and then page 8, that's all I care for. Oh, okay. I'm right, so I'm just gonna be able Tran-Bloom, I was here yesterday, so I don't have so much more. So this is so much too. Oh, then I gave it to me. Yeah. It's okay. Can I come back? I'm gonna exit out and sign it up. Okay. And then later I just have the sands anyway. Okay. Alright. It's called Oh, alright, so 43 is one of them. Okay, number 20 was the last 20th. Right there, and then last seconds. Okay. Oh, yeah.
My brain doesn't work.
Oh, hey, it's the.
So my brain.
It's this one. It's a little everything, right? Can I just do that? Okay. Good? Anytime there's zeros. Alright. B! Here we go, boys. Alright, Jason, what quadrant is your theta in? What do you draw your triangle? I'll have a B. Shh, Jason speaks.
This session is under.
Oh, dang it.
Is there an option like for
You know, I don't know if my Google thing has an option. Is there an option that I will extend this?
what's it called?
Ben, can you go and like enter this in for me? This is the Google Chrome remote desktop. All right, Ben, 12 digits. Here we go. 4883. Oh no, access. No, not share. Okay, 4883. 6998. 1727. All right, share. We're good. Thank you. Hey, if one of you guys are really good at this computer stuff, can you find out if the Google Chrome remote has an extended life? You know? Huh? Oh, no, don't know, Okay. All right. Sorry, Jason, what quadrant do you want the triangle to be in? 1, you said?
4.
I'm sorry, 4. I'm really old. I can't hear. Okay. What are you going to do? with this triangle?
You put in the sides.
Uh-huh.
So for the hypotenuse, it's going to be -3, and the opposite of the theta is going to be 1.
Oh, is that all right? Check it for me. Is this legit?
-1 and then positive.
That's okay.
Is that legal?
Doesn't matter.
Does it? Does it not matter? Shh, I can't hear Benjamin. I mean Nathaniel.
Value goes down, it would be negative there, and the hypotenuse is always positive.
Okay.
Oh.
Yeah. This is somewhat illegal. Okay. Your negative should go with the x and y variable, right? And the reason is that if you put a -3, guess what happens when I find sine? Then you would have a negative answer, wouldn't you? But that's not true, because in quad 4, what? Cosine is positive, okay? Let's find the missing x, though. What do?
So hypotenuse is
Pythagorean theorem. So here we go. X squared plus, yes. Hypotenuse can never, ever, ever be negative. All right, so that means x squared equals 8. Is that okay? X is rad 8. Can I leave it like that? No, you may not. Please root it and simplify. So 2 rad 2. This whole thing is just an angle. Let's call this angle what? Theta, alpha, beta. Pick a Greek. Go with it. All right, so then cosine of that same angle is just simply 2 rad 2 divided by 3. And that is as, oops, I meant 2 rad 2. And that's as far as we're going to go. Did you guys get C done? Yeah? What angle did you draw that in? I mean, what quadrant, I should say. Second, okay. Second. Okay. Cosine, remember, cosine inverse is restricted from here all the way to here. Okay, so that's why it has to be in second. Let's label this. This is -1, right, y'all? This is 3. So the y value is, oh, it's the same ratio. So what's that? 2 rad 2. Okay. So then tangent of the composite of cosine inverse -1/3 is what? Negative 2 rad 2. Okay. Because tangent is y over x, and x is -1. Bless you. Questions at all? No. Are you sure? All right, let's move on to graphing cosecant. How much graphing do we remember about cosecant?
It's like all of. How do you find the restrictions again?
What do you mean? You go back to the definition of the inverse. So we defined those inverse functions, remember at the beginning? And we wrote the domain and range of those inverse functions. That's where the restriction, that's why we keep coming back to it. Okay? We wrote like what quads they belong in. Like it's the range from where to where, depending on the function, and then the range from where to where. Okay?
What I do is I went from.
Right, teams. In your team, you have 5 minutes. I would like for you to graph out cosecant.
Oh wait, no, that's not. No, you have to do that. You're right. You can't do that because
Okay, talk to your peeps. Graph out cosecant.
Oh no, that's a constant. Except for 0.
I live here. This is my house.
Okay, so. Asymptotes are at 5, like every, yeah, 3, 5. Where does it go again? Like you can't equal sideways.
Just like the ratio of the exponents are kind of
Oh, then
different.
it
This all just
then
kind
it's
of like drop around.
y can't equal 0.
It didn't really matter. It's just like they were.
No, it's X.
Which way does it go? It's like above 1.
All right, class. Cosecant is the reciprocal of what? Sine. Okay, here we go. Give me sine. Okay, I'm asking for sine and only sine. Sine at 0 is what? 0. Sine of pi over 2 is what? 1. Sine of pi is? Sine of 3 pi over 2 is? And sine back of 2 pi is? 0. Now cosecant is the reciprocal. What happens when you flip all the 1s to negative 1s? What happens when you flip all the 1s to negative 1s? It's still what? Yeah. What happens when you take the reciprocal of 1? 1. What happens when you take the reciprocal of negative 1? Oh. Well, what happens when you take the reciprocal of 0? Yes. So all you do is go and put zeros, these, okay? So those are the asymptotes. We will start at 0. Yes, asymptotes are really important on these. And at pi. And at 2 pi. And at negative 2 pi. Then the other ones, I'm just going to make a dot at 1. And negative 1. And negative 1. And 1. Okay? And because I only have 1 dot and I have to hug the asymptote, these will be what? Parabolas. Okay. Are these 1 to 1 by the way? No. All right, Josh, you got invited to a group of mathematicians and they said, you know what? You have to cut this in pieces so that way it gets a 1-to-1 definition. Where would you cut off?
Negative pi over 2 to pi over 2.
Josh! Oh, never mind. Not Josh. Okay, not Josh. Sorry, Miss Josh.
Oh, I'm so sorry.
Me too. Me too. I apologize to Josh Summer. I meant the other Josh.
You say 0 and then pi over 2.
So Josh K said 0.
Another Josh, come in.
Oh, there's one coming. Tag team. Okay, tag team deal, Josh.
Negative pi over 2 to pi over 2.
So the other Josh that add on negative pi over 2?
You did it, Josh.
Okay. So the Joshes got it? Okay. That is true. We are going to take it from negative pi over 2 to positive pi over 2. It's definitely currently not 1-to-1. Okay, so because we said no, we need to restrict it. What's the whole reason for restriction? Yeah, make it 1-to-1. Restriction. Here we go. Do I include negative pi over 2? Yes, it is a value that we can use. So negative pi over 2. All the way to 0. Take a break because there's an asymptote. And then continuation all the way there. Okay. Just like what we did with tangent, cosine, and sine, we are now going to attempt to define cosecant inverse. How do you find an inverse of any function? Switch x and y. Okay. Then we would try to solve for y. So y, because it's an inverse, we use the notation of f to the negative 1. Then we're going to go, hey, compose both sides by cosecant. We use a negative 1 in this class. Now, your book uses negative 1, but last year, some of you have mentioned you can also use what? Art. Yep. Either way, I will accept. Yes.
Question. Why is 0, 0 an asymptote? Because isn't the reciprocal of 0 still 0, so wouldn't that be a valid point?
Oh, is the reciprocal of 0, 0? 0 over 1, right? Is 0? I flip it, so 1 over 0? Yeah, so when you flip 0, it's undefined.
Okay.
All right, let's lay out all the domain and range. Ready? Domain. Okay, domain. And this is the whole team, okay? So Justin, your entire team, come up with a consensus what the domain is for cosecant inverse? Teamwork.
Is it okay for like the universally we have decided to restrict the domain? Instead of doing union, can we just do negative pi over 2 pi over 2, but then for x does not equal 0?
Maybe just use brackets on both sides. That's only one aspect.
So we have an answer? Yeah. Justin's team? All right, give it to me. Negative infinity, I'm sorry, to a negative 1 inclusive. Good job, Justin. Good job. Thanks, team. Range. Okay, so this is your whole team. Here we go. Sarah, entire team. What do you want to say? Do you guys agree? Oops, sorry, it's supposed to be not inclusive here. Okay, and you know, more often than not, I would just say the quadrants. Okay, so what quadrants? What quadrants should we mention here? It's also 1 and 4, right? Would you guys agree with that? 1 and 4? Okay, so let's look at y's 1 and 4. Because on the unit circle, this is pi over 2. This is back to the unit circle. And this is negative pi over 2. So it's 1 and 4. 1 and 4, which is very much the same as what other inverse functions? Sine and tangent. Okay, so far we have 3 that are in 1 and 4. Okay, let's graph it out to see what it looks like. By the way, is the reciprocal function the same as an inverse function? No, okay. Cosecant is the reciprocal of sine, which is definitely not the same as the inverse function of sine. Would you agree? Okay. Let's graph out both. Okay, restricted. So we're going to go as far as pi over 2, negative pi over 2, up pi over 2, negative pi over 2. Then I need to put a 1 in. 1, it's 1/3 of the way, 2/3 of the way. Which way? 2/3. So here's 2/3, so that's 1. This is 1. This is negative 1. This is negative 1. Okay. We'll start with the parent, with the restricted one. So cosecant of x. Should we put the asymptote right away for y equals cosecant of x? Yeah, so at 0. Here's the parent function for cosecant. I only have 1 dot on the right. Cosecant on the right has a dot at where? Yep, pi over 2, 1. There's 1 dot. With 1 dot, how do you know where you're going? Curving towards what? The asymptote. That's why we have an asymptote. It approaches that. Okay. So that's all you are doing on the right. On the left, you also have 1 dot at where? Yeah, negative pi over 2, negative 1. And again, you're curving towards your asymptote. Okay. So this blue one is y equals cosecant of x with a constraint, with a restricted domain. Okay. Then now I need to graph its inverse to see what it looks like. Should I put an asymptote in?
Yeah.
Where? Yeah, you're right. You're both right. Then now I need 2 dots. Give me 1 dot. 1 pi over 2. I have 1 dot. How do you know where this is going? That's right. Okay. What's my second dot? What's the second dot? Negative 1, negative pi over 2. Okay. And again, go towards your asymptote. Okay. Now, if I'm really, really good, okay, do you think this graph is symmetrical about this thing called y equals x? Yeah. Now look at the orange-ish looking color. That's the reciprocal function, not reciprocal, I'm sorry, the inverse function for cosecant. Does that look like sine? No, right? That does not look like sine. So that's why the reciprocal function and the inverse don't look the same. All right, 5 more minutes. Your job is to graph out secant. 2 pi to negative 2 pi.
Okay, so let me start my sim.
On 1, 2, and 3, okay, and then the second page goes to 43. Keep on going. 7 and 8. Great. The other Josh. Josh K and Josh S. You can talk.
No, you meant to know.
That's not part of negative pi over
No, wait, I can't do
All right, I'm only going to be asking for cosine, okay, because that's easy for me to start with. Because I think a lot of you are more comfortable with cosine anyway. Okay. Cosine, here we go. Okay, so cosine. Ready? Jack, what's cosine for 0? 1. Perfect. Okay. Chase, what's cosine of pi over 2?
Cosine of pi over 2 is 0.
Great. Okay. Nathaniel, what's cosine of pi?
-1.
-1. Ian, what's cosine of 3 pi over 2?
0.
Awesome. And Isabel K, what's cosine of 2 pi? 1. Is that okay? Because secant is the reciprocal, all the zeros are now what? Asymptote. So an asymptote pi over 2, an asymptote at 3 pi over 2, and so on and so on. Okay. I have a dot at 1, so I'm going to make a dot, -1. Okay, so here's a dot. Here's another dot. Here's another dot. All right. Is this a 1-to-1, Rasmus? No, because you said no. We have to restrict it, my dear. So it can be a 1-to-1. All right, you are in charge of the meeting. What do you want to restrict? Shh. Wait, Rasmus speaks.
Inclusive from 0 to pi.
Inclusive from 0 to pi. Is he right? He is partially right. From 0 to pi, except x cannot be pi over 2. All right, to be continued.